Right, now that we know what factorials are, we can use factorials to calculate combinations and permutations. So let's introduce what those are and how we can calculate them. All right. So let's say we've got 10 letters, A, C, F, G, etc., and we want to pick 3 of them. Question is, how many different possible combinations of 3 could we pick? All right. Well, that'd be an interesting question. And here's how we would calculate that. Okay. We would take well, let's just look, for example, A and F and G, C, F and H, W, K and R. There's all these different combinations. And one thing to note is when we say combinations, the order doesn't matter. So in other words, ACF and FCA and FAC, any order I can put those in doesn't matter. So those are just 3 that I would pick. I don't care which one I picked first or second. Those are combinations. And here's how we're going to calculate how many possible combinations there could be. And again, we're going to use that factorial that we've learned. But here's how we write the notation for combinations. If I have 10 items and I want to pick combinations of 3 or groups of 3, I would write it like this: the small 10, a capital C, and then the small 3. And we read that as 10 choose 3. And the number of ways we can do that is going to be 10 factorial over 3 factorial times 7 factorial. Okay? And we'll talk about how we got that in a minute. When we calculate that, we get 120. There's 120 ways that we can choose 3 letters out of a group of 10 different letters. Okay, here's the formula that we used. Okay, in general, we call it N choose R. N is how many we have to begin with. R is the size of the groups that we pick. And C stands for combinations. So we read that as N choose R usually. And the way we calculate that is N factorial on the top of the fraction. Then underneath we do R factorial, the number of the size of the group, and N times N minus R factorial. So that's where that 7 came from in the example above here. All right, I'm choosing 3 out of 10. So it's 10 factorial over 3 factorial times N minus R, or 10 minus 3, which was 7 factorial. Okay, now the other thing is we can do this on our calculators depending on which one you've got. They both have this function on there. So you can type in the 10, go to this function, depending on your calculator, hit the 3, and it will calculate the 10 choose 3 for you. All right, but here's how the calculations go with the factorials if you wanted to do it that way also. All right, how about permutations? What do those mean? Well, here the order matters. Remember, in the combinations, we said A, B, C, and C, B, A, for example, would be the same. Now, those would be considered different because the order would make a difference. We care which one is first, second, or third for whatever reason. And we would write that as N, capital P, and a small subscript R. The N and the R are small like subscripts, capital P. And we could read that as N permutations of R. Okay, where R is our ones were of the size R that we're going to pick them. N is how many we start with to pick from. And calculating that would be N factorial over N minus R factorial. All right, so back to this example, if we're picking groups of 3 out of 10 letters to pick from, we would do N capital P 3, 10 P3, so 10 pick 3 or 10 permutations of size 3. And based on our formula, then it's 10 factorial over 7 factorial. All right, when we calculate that in our calculator, we get 720. And just finally note how much larger that is than the combinations. Combinations, where order doesn't matter, again, that ACF and FCA and CFA, those were all the same. Now, if I'm counting each of those as different, instead of 120, I've got 720 different groupings or permutations I can get from these 10 letters, okay?